Alright, so the theme of this video is going to be unit conversions, as you can tell by the header. Pretty much this video is going to be the intro or the kickoff video to my calculator section of the channel. If you'd like, you can just go to my Patreon. I'll be linking it in the bio of all of my videos. It offers these calculators that you'll be watching me make in the next few videos in one big calculator called the Master Engineering Calculator. It's got stuff for temperature, it's got stuff for pressure, energy, power, quick calcs for flow to pounds and flow to kilograms and things of that nature. But if you'd rather just watch all these videos that I have and watch how I build these calculators, you can go ahead and do it for free on your own. And if you'd rather go to my Patreon and subscribe, you'll have access to download that content. So the reason that I'm making this video is because while I make all of those videos that I was just explaining to you that you'll be seeing if you continue watching the series, I do a lot of work in Excel and I do a lot of unit conversions just kind of on the fly, and I might just talk and say what I'm doing, but you won't actually physically see what I'm doing. So for lack of a better word, I wanted to put pen to paper and just go over some basic unit conversion examples here. It's really going to be one big example, but it's got as many units as you could ever want to deal with. So without further ado, I'm going to go into a concept called turbulence. And when dealing with turbulence, you will be talking about something called the Reynolds number. It's subscribed RE, and the formula for it is rho VD over mu. That's the Greek letter mu. Please forgive my penmanship. And for this example, I will tell you that rho is density. This is for those who don't know this off the top of their head. I guess I'll start by defining it. Rho is density. Little v is velocity. D, diameter. And mu is dynamic viscosity. Now, one thing I will tell you that will help build this relationship is that Reynolds number is unitless, meaning all the units have to cross out. So let's do a example where I tell you that your density is 250 grams per liter. I tell you that your velocity is 100 meters per second. It's very fast. And I will tell you that your diameter, or the diameter of your pipe that this is traveling through, is 36 inches. Actually, you know what? That's going to be a very insane number. So let's do 12. Let's give it a 12-inch pipe. And your dynamic viscosity is going to equal, I don't know, come up with the number here. We'll do 2,500, and I have it in my notes here, but I want to make sure I do this. I gave you guys some crazy units here, and I did it on purpose. And I want to make sure I give these crazy units as well. Yeah, that's right. That's right. So we're going to do PSI. times second. So there you go. Take all of this information, do with it what you will, but the first and easiest thing to do is going to be to determine common system. This is your step one, very first step. So you have grams, which is metric, you have liters, which is metric, you have meters, which is metric, and then you have inches and PSI, which are English or American standard. So you have 2 that are the American standard and 3 that are the metric system. This would lead me to go to the metric. So we've determined, we'll say, we'll call it metric. Check that box off. Give it a bullet point, I guess. So now the next thing you'll do is you will go ahead and go and convert your inches. So let's do an inches conversion. We'll do 12 inches, and then you're going to multiply that by 1 inch is equal to, and I have my conversion sitting next to me. 1 inch is equal to 0.00254 meters. 0.00254 meters. Inches go away, inches go away. You are now left with is going to be 0.3048 meters. 0.3048 meters. And now you have PSI. That's a unit of pressure. Let's do PSI to it's going to end up being a Pascal. So if we're looking at kinematic viscosity, and we have 2500, this is PSI times second, we will multiply this whole thing by 1 Pascal, which is equal to 0.00014545038 PSI. This whole thing will lead me to it's going to be a lot of pascals. I'm going to go ahead and scroll a little bit over here. It will give me 1.7237 times 10 to the 7th. That's what that E stands for. It's called scientific notation. So now we have these values. So we can now plug them into one more Reynolds number formula. So RE equals, I still have my 250 grams per liter. It's this guy. You're going to multiply by, like I said, 100 meters per second. Now you are going to multiply this by 0.3048 meters. Square this, square this. Good. Divide the whole thing by your 1.727 times 10 to the 7th. And this is in pascals times second. So one thing you'll notice is we did 2 unit conversions. We went from inches to meters and PSI to pascals, and we still can't cross anything out. So what you're looking at right here is all metric. This is the point in me making the video. So let me go ahead and just cross all this crap out. Make it so you can see kind of what I'm talking about. So separate everything we did up top. And just look at what we have right here. Every bit of this is metric. However, nothing cancels. Yet. So you will have to do even more unit manipulation with this. So in order to do so, I will highlight these in green. One thing to note is that a pascal equals a Newton per meter squared. And a Newton per meter squared, if you remember the second law of Newton's second law of motion, you will remember that a Newton is a kilogram meter per second squared. And then if you were to divide all that by a meter squared, it would look like that. And then you can flip this function. I don't even want to draw an arrow. I just want to draw a equal sign is really what I want. Bam. And let's do equals. And we will do kilogram times meter. I should put time. Kilogram times meter per second squared multiplied by 1 over meter squared. That's the same thing as what that is. One of these meters goes away. This meter stays there. Ergo, 1 pascal is equal to a kilogram per second squared times meter. That's a pascal. This right here is one of the fundamental identities we're going to use to get this thing to be unitless, because I said at the very beginning of this, don't forget, your Reynolds is unitless. That's how we got to check this out. So we will go back to the green. Another thing that we will use here is a liter. A liter is equal to a decimeter cubed, which, if you remember, would equal a decimeter times a decimeter times a decimeter. Now, what you can do is you can go take it a step further, and you can say a decimeter divided by 10 times a decimeter divided by 10 times a decimeter divided by 10 would indeed equal a meter times a meter times a meter, which would essentially be a meter cubed, right? Makes enough sense. So this conversion right here is divided by 1,000. So what you can do with this piece of information as well as this piece of information is you can imply that a liter equals a meter cubed divided by 1,000. That's what you got. So, yet another fundamental identity that you're going to use to get this puppy to be unitless. Liters is a meter cubed divided by 1,000. A Pascal is a kilogram per second squared times a meter. So let's plug these back in to our original equation up here, right? I will do 250 grams per liter, so bear with me while I write this again. RE equals 250 grams per liter multiplied by, what did I say, 100 meters per second? Yeah. 100 meters per second multiplied by 0.3048 meters. 0.48 meters. And what did I say right here? A liter is a meter cubed divided by 1,000, which would mean a meter cubed is a liter times 1,000. So I'm going to go like this, times, we will do, a liter is a meter cubed times 1,000. So we'll do 1 liter, and then we'll do meter cubed times 1,000. This liter is going to cross out with this liter, and while I'm at it, every time I do a unit conversion in the middle of the big Reynolds calculation, I'm going to go ahead and do this. There you go. Bam. And all of this is just the numerator. This is going to be divided by, matter of fact, while I'm at it here, let me just go ahead and erase that shit. And we'll do Reynolds number equals this whole big thing. And then, what did I say? 1.7237. 1.7237. 1.7237 is that times 10 to the 7th. So if you had a point here, it'd be 1, 2, 3, 4, 5, 6, 7. It's going to be 17,237,000. That's going to be pascals times second. But wait a minute. I said it earlier. We're going to do pascals times second. But what did I say up top? Pascal is a kilogram per second squared times meter. 1 Pascal is a kilogram per second squared times meter. This whole thing is going to be, I'm sorry that got sloppy, but your Pascal will cancel out with your Pascal. And now let's do some math and condense this crap. It's going to look a lot better. We'll do 250. We'll multiply that by 100. We'll multiply that by 0.3048, and we will divide that by 1,000 at the top. And on your top, you're going to be left with 7.62. This will be grams times meters squared. You see where that comes from? You have a meter here and a meter here. And it's going to be divided by meters cubed times a second. Both of these meter squareds will go away, and this will only be left with 1 meter. So you see that cancellation. And then your division problem will give you 1, 7, 2, 3, 3, 7, 0, 0, 0. This will now be kilogram times second per second squared times meter. Everybody see what I did there? So this second will cross out with one of these seconds, and you will now only have a second in the denominator. Flip the fraction, this fraction rather. Bring it here. Get yourself something that looks nice. You will have 7.62. Like I said, the meter squareds canceled out, so you're going to have grams per meter times second. This is your numerator. And you're going to multiply by 1 over the denominator, which is the same thing as just dividing by the denominator. It's easier to look at it this way. You will now have seconds times meters divided by kilograms. But instead of just kilograms, I'll make sure to write the number. I know it's a long pain in the freaking butt number, but 7,237,000. This will be kilograms. Boom. Boom, boom, boom. What do we notice? We got meters, we got meters, we got seconds, we got seconds. We got grams, and we got kilograms. So while we're here, let's go right ahead. And I just realized I forgot to do something. I apologize, everybody. This is a circle. I want to circle this. This is the other unit conversion that you had to do. Boom. So grams divided by kilograms doesn't make a whole lot of sense. So let's do 1 kilogram is the same thing as, you guessed it, 1,000 grams. Boom. Equals, we now have a ridiculously small Reynolds number, so it's going to be 7.62 divided by 17237,000 times 1,000. And this math, unless I'm mathing wrong, which would be very embarrassing, but I'm not afraid to admit I've done it before. 4.4207 times 10 to the negative 10th kilograms will cancel with the kilograms, and the grams will cancel with the grams. You now have achieved a unitless number. So why the heck did I go over all of this? Well, the main reason I went over it was to emphasize this. A lot of people think that once you get something locked in tight, you can just say, oh, I'll just turn everything into the metric system, and once I turn it all into the metric system and get it out of the English system, I'll be fine. So you pick a common system, ends up being metric, then you convert your inches to meters, you convert your PSI to pascals, and then you go down here and you try to plug it in, and you're like, nothing, literally nothing cancels at all. Not even these seconds. This second doesn't cancel with that second because it's just a flip. So that would actually be second squared. If you were to combine these together right here, you would multiply this whole thing at the top by 1 over this. You would get grams times meters squared divided by liters times seconds squared times Pascal. And everything's in metric, but nothing cancels. Yet, I told you it was a unitless number. You have to find these things. I tend to call them different stuff, but you could call it auxiliary relations or relationships, rather. Like I say, like a Pascal is still, I mean, it's definitely a metric unit of pressure. And a liter is definitely a metric unit of volume. But in order to get this thing to be unitless, you have to start playing around with what is a liter in terms of meters and what is a Pascal in terms of kilograms and seconds and meters. You need to get all these things rearranged in such a way that it will spit you out the right number. Because I will tell you right now, this Reynolds number is goofy. It doesn't make any sense. And the reason it doesn't make any sense is because I so happen to choose an insanely large dynamic viscosity here. An insanely large dynamic viscosity. And that's what is going to give you a ridiculously small Reynolds number. 250 grams per liter isn't the craziest density. 100 meters per second. I mean, it's pretty fast, but it's not the fastest thing on Earth. And then 12-inch pipes, pretty standard. So, nevertheless, with all those crazy random numbers that I just made up off the top of my head combined, it would get you this Reynolds number. And I want to reemphasize, like, why is this important? Well, I said it's this topic is called turbulence, right? When you solve for the unitless Reynolds number, depending on what that Reynolds number is, it will tell you whether or not your flow profile is laminar or turbulent. Whether or not it's laminar or turbulent will dictate how you calculate several other things based on your flow profile. So, very important number, has to be unitless. If it's not unitless, you're not using the right number, you won't make the right decisions, and you won't calculate the right things based on the decision you make. So, again, I hope this emphasizes what I'm really trying to do is converting units. It emphasizes how important it is to convert units and how you can't just put everything in metric and hope that you're good. You have to make sure that all of your boxes get checked and crossed out. And in these videos, like I said, I will be doing this at a much faster rate, and I'll be doing it in Excel spreadsheets, and I'll be talking about what I'm doing. It's much easier to kind of visualize it this way, in my opinion. So thank you guys again for watching this video, if you stuck it out, and best of luck to you in the future. Hope you use this stuff. And swift reminder, if you want to, you can go right ahead and get into the description in the bottom of the video, and you can download these calculators that I'll be going over off of my Patreon website. So thank you guys so much, and best of luck.